I'd like to do problem number 32 off of page 229, which makes me think about the binomial distribution. So we have instructions here. Assume that hybridization experiments are conducted with peas having the property that for offspring, there is a 0.75 probability that a pea has green pods, as in one of Mendel's famous experiments. All right, well here in number 32, assume that offspring peas are randomly selected in groups of 16. The instructions here giving me the probability of success. We're going to be counting green peas. Find the mean and standard deviation for the number of peas with green pods in the groups of 16. Well, this is a binomial procedure. We're collecting groups of 16, so that's our fixed number of trials. The trials are independent of each other because one pea pod doesn't affect the next, or one plant doesn't affect the next. The probability of success is told to us to be 0.75, coming from one of Gregor Mendel's very famous experiments. And we definitely have two categories. We're counting green peas or not green peas. So that's our binomial process. And we're using this as a fixed probability in each trial. So we know that the mean mu, well, that's just n times p. The standard deviation sigma is the square root of n times p times q. Well, q is the probability of failure. 1 minus p, well here 1 minus 3/4 is 1/4, so 0.25. So that's going to let us write down a mean and a standard deviation. All right, well 3/4 of 16 is 12. So I'm going to write 12.0, thinking about a round-off rule. So 12 green peas. The standard deviation, the square root of 16 times 0.75 times 0.25. All right, well, we'll get our TID3 out here and find out that that comes to about 1.7 peas. So there's the mean and standard deviation that part A asked for. Part B, SS2 use the range rule of thumb to find the value separating results that are significantly low or significantly high. Well, the value that separates significantly low from the typical data, that's the mean minus 2 times the standard deviation. So 12 minus 2 times 1.7. Again, we can use our calculator. So 12 minus 2 times 1.7 comes out to 8.6. The value that separates the values that are significantly high from the rest, that's the mean plus 2 times the standard deviation. So 12 plus 2 times 1.7, 15.4. We have identified the values that separate the things that are significantly high or significantly low. Anything below 8.6 will be significantly low. And anything above 15.4 will be significantly high. Well, I only have an option to go up to 16 and I start at 0. So the things that are significantly low, well, that would be anything below 8.6. So any of the values between 0 and 8 would be a significantly low number of peas. And the values that are significantly high, well, that would just be 16. That's the only possibility that's over 15.4. Anything between 8 and 6, anything between 9 and 15, the values between these, those are typical. All right, and part C finally is a result of 7 peas with green pods significantly low. Well, yeah, it's on my list there, and it's on my list because it's less than that 8.6. What's really going on? 7 is significantly low because it is more than 2 standard deviations below the mean. That's what this calculation does. It identifies 2 standard deviations below the mean. Anything below that, that's significantly low. All right, well, there's the example I wanted to do about the binomial distribution. That's it for now.